Hi, my name's Pasquale DeMaio. I'm a program manager on Windows. I work in the server area, particularly on an area called Headless Server. So today we're going to talk a little bit about remote emergency and bring up management. First thing I'd like to do is introduce you to some of the terms and concepts that are key to understanding how the whole concept works. Number two, so I'll talk a little bit about what we're doing for Whistler. And number three, I'll wrap up and we'll sort of discuss where we are. And I'd like you guys to feel free to ask me any questions during the course of the presentation. So first, let's start with what a headless server is. A headless server, the idea is that you don't need a keyboard, a mouse, or a monitor attached to it. Obviously, I'm sure this idea of rack mount servers is clear to you. Basically, we want to make it so you never have to access the server unless you need to change out hardware or something like that. There's going to be a quick poll question here, and that'll be coming up. And if you could take a second to answer that, I'd appreciate it. Okay, so the first key concept I want to talk about is the idea of system states. It's one way to look at how a system's life goes. If you take a system, its very initial state is power off, the system power ons, and then you go into the firmware state. On a PC, that's the BIOS state, where you see posts, and you go through the memory counts and things like that. As the system progresses, then the OS loader starts, and it begins to load the OS. As the OS loads, the kernel initializes, and at some point, you reach the OS state. This is the state where the OS is fully manageable and where you want the OS to always be, obviously. When Windows is in this state, you can use the network. It's doing its functions. It's running as your IIS server or as your SQL server, the typical things you expect your OS to do. The OS can enter a state of distress where maybe something is going wrong. Maybe there's a memory leak or something like that. And your goal is to always get it back into the OS state. Occasionally, we will have a blue screen or a system hang. Obviously, Windows 2000, we did a lot of work to eliminate that, and we continue to do work on that for Whistler. Similarly, there's a set of states like that for setup. The setup states, none of them are really manageable via the network. So the goal is always to get the system into that OS state. That's where the system is useful and usable and manageable. But during the rest of these system states, managing the system can be very important. Obviously, you want to be able to set up the system. Obviously, you want to be able to get the OS started. And obviously, if there's a failure, you want to be able to come back and fix it. So let's talk a little bit about different ways you can manage a system. One of the mechanisms is in-band management. This is the mechanism that you're probably most familiar with. This is MMC snap-ins. This is terminal services. This is coming in through Telnet. This is the typical way you manage the system when everything's working fine. Now, in those cases when the system isn't working fine, you need an alternative. That's when you need what we call out-of-band management. Out-of-band management is management that doesn't rely on the network card, or I should say doesn't rely on the network stack in Windows and the Windows management tools. Instead, we need to rely on other options that aren't as reliant on the OS being present. This is how we deal with those states other than the OS state, where the system may be in firmware, where the system may be loaded, where the system may have had a blue screen or be hung. So when you look at the in-band state, the OS handles all the security, and we use a network stack, as I mentioned. When we look at the out-of-band state, security varies. The medium varies. It may not be a network card. It may be on a serial port. It may be on some other device in the future. The out-of-band obviously needs to be more reliable, the most reliable management network, because if it isn't reliable, when the system has problems, you won't be able to get to the system. So let's talk a little bit about what's available for NT4. On NT4, there was a lot of work by third-party companies to try and make the system manageable when the OS wasn't running. Key features there were redirecting BIOSes. BIOSes that would put their output on a serial port. So you could plug a serial cable into it, and then you could view what was happening. BIOSes, some systems from OEMs had onboard ASICs, or service processors. These service processors allowed the BIOS to be redirected, and often they would also redirect something that was in text mode, like DOS or maybe the Windows loader. And they would also sometimes offer some sort of support for doing things like resetting the system if the system had been failed, or if the system was just in an unknown state, or you had changed the firmware setting and you need to reset it, things like that. Now, OEM boards offered a more powerful solution typically. Often they would have a network cable that could go into the back of them, and you could actually access your system even when it was in a failed state via the network. All of the infrastructure for running that network, the drivers, the stack, were contained within that management card. Typically, these cards would only run on a specific OEM's platform. For instance, an IBM card in IBM, a Compaq card on a Compaq, and they would vary in functionality in the way you access them. Some of them would offer telnet, some of them would offer proprietary interface, some of them would send SNMP traps. Most of them only did text redirection, but now some of them are starting to do graphical redirection, which is pretty cool. So you can actually see what would be on the screen even when Windows is loaded and entered a graphical mode, as well as the text screens from DOS or other places. Other technologies that were available were intelligent UPSs. You could obviously plug in a UPS to your system, and you'd always be able to keep the power up if you lost power. But some of these UPSs could be addressed, and you could control them remotely to reset the system by cutting the power to it and then bringing the power back on. And finally, there were serial consoles offered by companies like Seattle Labs that allowed you to access the system when it was running via the serial port in case you had a network issue, things like that. There's some really good work done by an engineer named Robert O'Brien here at Microsoft in the ICU group. And what he's done is he's kind of taken a lot of the best practices and the tips and tricks for running an NT4 system and now a Windows 2000 system as well. And he's kind of brought them all together in the forms of these README files. There's a PPT and a doc file there that should give you a lot of hints on what you'd want to do if you were trying to run a system headless on NT4 or Windows 2000. Some really good work, so feel free to check that out if that's one of the things you're interested in. So now I'd like to tell you a little bit about what we're expecting in Windows Whistler. In band management, we're going to keep improving the tools we already have, and we've done a lot of work. Terminal services for administrative mode is much better, in that now you can access the actual local console with it. In the past, you could occasionally have a pop-up that would not be accessible via terminal services because you couldn't get at the actual local console. You'd only get a console of the system. We've eliminated that problem with the new administrative mode. It continues to be a two-user license to come in and administrate it. The first license is for you to actually do the administration work. The second license is there for redundancy in case there's a problem with the first one, or in case somebody goes home and leaves themselves logged into the system, you can still access it from another location. WMI. WMI, the Windows Management Infrastructure, is how we are instrumenting the operating system. You're probably familiar with it. There's probably even been some other talks on it. But the key here is to know that we really keep administrating more and more of the operating system until we reach the point where the operating system is entirely instrumented via WMI. It's an industry standard. It's very cool. It allows interop between other OSs and also interop between lots of different vendors' management solutions, these third-party solutions. So WMI is something that we will continue to drive forward and should make your life better. It also allows a lot of scripting, which is my next topic. Windows Scripting Host continues to be a key part of the management story. The resource kit is an excellent source of other scripts and things, so you can get ideas on how to write your own scripts, and also just lots of sample scripts that are probably useful just in themselves. Telnet daemon will be included in the server product again. It'll be a two-person license similar to the terminal services. And once again, you can use your favorite Telnet and command line applications to manage the system. Finally, MMC. We continue to drive MMC to make it a management solution that's available, the typical control panel type applets and things like that, and making them more and more remotable. Finally, obviously, probably most of you use at least one, and probably most of you use 2 or 3 third-party management suites to drive your management of your Windows systems. And those obviously continue to work, and they work very closely with the WMI team to make sure we are instrumenting the operating system in the ways that are appropriate for them to provide the kind of solutions they want. So it looks like Okay, I thought I had a question, but it turns out it was just offering to let you guys ask questions. So, my apologies. Continuing on, hardware dependencies. If we take a look at Windows in the past, it's always required to have a video card, a keyboard controller, and it was pretty useless without a keyboard, mouse, and monitor attached. And the keyboard, mouse, and monitor problem was addressed in a lot with Robert O'Brien's work. But in Windows Whistler, we're looking at taking out the requirement for a keyboard controller on an ACPI system, or I should say we're not looking at it, we're doing it. We're also adding a null VGA driver that allows you to remove the video card so that you can actually run a system that doesn't have a video card in it if your OEM provides a system that will boot that way. And more key and even more important is the fact that we're going to remove the requirements with the keyboard, mouse, and monitor by adding this capability that I'll talk about in a second for using our emergency management services. So here's the emergency management services story. It's a small, reliable set of out-of-band management tools. The key concepts here is that it doesn't replace your in-band management, your MMC, your terminal services, your telnet. What it does is it augments them for situations, the states we talked about, where the OS isn't present. Now, obviously, we can only handle the states where we have software running, which would be in the loader or before the kernel is fully initialized, when we've blue screened, in some occasions when we've hung during setup. But during those cases, we're going to offer you a set of tools that are available via the serial port. This is going to be on COM1 or COM2. It'll be 9600 baud. What we went for was Unix interoperability. 8 bits of data, no parity, 1 stop bit, and VT100. We've also added a couple of extensions. They're not really extensions. You can plug a VT100 terminal directly into the serial port, and it should work just fine. What we've done is we're just specifying some escape codes that are more conventions for use, so that what we'd like to do is drive OEMs to implement the same kind of escape codes in their hardware. Hardware integration is one of the key points to dealing with any out-of-band situation, because as when I showed you the state diagram, it was pretty clear that there were a couple states there where there was no Microsoft software running at all. The power off state, the firmware state, and in those states you're completely reliant on your OEM's implementation for your out-of-band management. We're working together with the OEMs to drive unified solutions in that space, because I know to you as a customer it's obviously not interesting to you why it doesn't work. You just want it to work, so we're going to make it just work. If we take a look at one of the key things to note is that the debugger, if you're one of the customers that uses the debugger, cannot run on the same serial port at the same time as the headless situation, because our out-of-band management solution uses a different protocol than the debugger. The debugger is not VT100 compatible. So let's take a look at what we're doing for some of the system states. In the loader, in text mode setup, in the blue screen, and in the recovery console, we're going to provide text redirection. These are all the states that appear to be text mode on screen. This does not include if you load up command in a window on Windows, or even if you do a full screen of the CMD window. It only deals with these actual screens where we're running the loader, text mode setup, blue screen, and the recovery console. And also remote install services. I wanted to take a special second to talk about those, because these can be really key in lowering your total cost of ownership by offering you a mechanism to remotely install your servers if you have a problem where you believe you have corruption of your disk or something like that. Remote install services is a mechanism to initiate a network install without having any software on the local system. What you do require is that you have a PXE card. Many cards are shipping with this. Sometimes it's called PXE, and it allows you to press typically F12 and initiate a boot to a remote server, which will then begin downloading Windows and install it on your local server. The local server could then boot and will finish the setup process, and you will have a fully functioning Windows on your system. With remote install services being supported on servers in Whistler, which is the first time we've done that, it opens you up to a lot of disaster recovery mechanisms that weren't there before. And we will be remoting all the tech screens there as well. If we take a look at when the operating system is running, I talked a little bit in the state diagram about how the operating system could be in distress. And if the system is in distress, then you need to be thinking about how you get it out of distress. Sometimes the system can reach a point where it's not responsive because there's been so much much traffic on it for security, or for some sort of system, some sort of application has a memory leak, or something has just been spinning the processor by making too many calls. When that happens and the system becomes unresponsive to the network, you need a different mechanism to come in and fix it. And so what we've done is we've created a thing called the Secure Admin Console. It also runs on the serial port. It's a high priority driver, so it will not allow another application to come in and cause problems that it can't, and prevent it from accessing the serial port and giving you its interface. It's highly reliable. It does all of its own memory management. That's key, because that way, if the memory is being sucked up by an application with a leak in it, it still can get all the memory it needs. It restricts itself to very, very few calls into other Windows components. So no matter what components are failing, in most cases, you'll be able to still access this thing. And finally, it runs at that very high priority. It offers a very simple command line interface with a very few set of commands. It's not command.exe. It doesn't offer a fully functioned shell. It's very specifically aimed at returning your system to the running and operational state. So let's take a quick look at what those commands are. This is a basic overview of the commands. We have a T-list, which allows you to see all the processes that are running on the system, and gives you their process IDs and how much memory they're using and how many cycles they're spinning. If you see a process that's really being offensive, you have a few options of what you can do to it. You can just kill the process. Obviously, if you kill certain processes, that can bring the system down, so you want to be careful with that one. But it's a very powerful tool, and we decided to err on the side of allowing you power versus trying to protect you from yourself, which I think is the right decision for good admins. The second one is we allow you to lower the priority of that process. If that process is spinning cycles and it's preventing all other access to the system, you can then lower the priority, and then you probably will be able to gain access back through the normal network mechanisms for managing the system. This is key. We also allow you to raise the priority so that if you lower the priority of a process too far, you can bring it back again to get your system running. If you lower a security thing too far, you'll never be able to get back on the system because security won't run. So we understand that there are times when you need to raise the priority as well. Once again, you can hurt yourself by raising the priority so high that that is killing your system. So obviously, be careful. Limiting memory usage. Limiting memory usage. Sometimes programs can take up too much memory. There'll be a leak, and they will prevent the system from being responsive. By using this, you can lock the amount of memory that this service or application can have. Once you've done this, the server will not allow that process to gain any more memory. This is a very powerful mechanism. You have to be careful with it as well. And one of the key things to note is that it uses the thing called the job object. I don't know if they've talked to you about that yet, but a job object is a thing that's in Windows 2000 and in Whistler that allows you to sort of control a process. When you use the job object, a process can only be in one job object. So if you've set up your processes to be in other job objects, you need to take into account their memory usage and priority issues beforehand, because we will not be able to use this mechanism to come in and change the process. Okay, it looks like I've got a question here, so let me see if I can take a look at it. Okay, the question is, how does RIS work with the Intel BIS integrated, which is boot integrity service? Little spelling error there, making a little brain error here. And And then it says afterwards that BIS guarantees that you are who you are, authorized to use the image. It's part of the pre-boot PXE features. And to answer that question, I'm afraid I don't know the answer to that. I am not a PXE or RIS expert by any means. I just understand the basic feature set. It's possible that we could get back to you on that answer. I don't know what the mechanisms are here for that, so I'm afraid I'll have to try and get back to you on that. Leonard, apologies. Okay. So another feature that we have here that we can do is we can take a look at the query and setting of IP addresses. Obviously, your system can become completely unmanageable if your IP addresses become incorrect. So we allow you to go in and set them and change them. We can query and set the system time. This was mostly added because certain security algorithms require system times to be accurate, or else they will not allow you to authenticate. And obviously, if you can't authenticate, you can't manage the system. Restart and shutdown, I don't think I need to explain what those are for. Crash dump is there so that you can make use of the ability to create a dump file, even if the system has become unmanageable, but it hasn't actually crashed on its own. So I believe that you'll be getting another polling question. So please take a chance and fill that out. Some key points I need to make on Windows Whistler. Headless is a server feature, not a professional feature. There's too much infrastructure required with the serial port. Typically, you need to either have a modem or you need to have a terminal concentrator to make use of it. Eventually, we might see it roll down into professional, though, if we can get a one-wire network solution or some other way to deal with the infrastructure issues. And also, the hardware involved will need to be inexpensive, I should say, typically, for people to be able to make widespread use of it. So let's talk just a key. I want to take a moment to kind of step back and mention those system states that I talked about a little bit, power off and firmware. If you're going to be buying a server to make use of this stuff, you want to make sure that your server also has redirection of its BIOS and possibly has a service processor ASIC on board so that it can allow redirection of the BIOS and also allow you to do things like resetting the system when you hit states that aren't manageable using our tools. Okay. So now I'm going to talk about two other support tools that are proposed right now that we're working on, and we're sort of investigating whether or not they have value to you as a user. So the first one is a thing called Bridge. As I mentioned before, the infrastructure involved in setting up one of these systems in a data center would typically consist of a serial cable running from the serial port into a terminal concentrator, which would allow you to telnet in and make adjustments to your system via that mechanism. So telnet becomes one of your key management tools for dealing with an out-of-band system by telnetting into that terminal concentrator. Currently, there's not a real good terminal concentrator available to make a Windows system act as a terminal concentrator. What we'd like to do is perhaps provide a tool that would allow you to set up a Windows system with a Rocket port or some other multi-serial port solution in it, and that would allow you to use a Windows system as a terminal concentrator. The way this would work is you'd telnet in, you'd get a command prompt, and then you'd load a terminal that would then talk to a serial port. Currently, our telnet daemon has some limitations due to VT100 compatibility with the command prompt. This is an area I think we should spend a lot of time on, but it also is important to note that this might cause some issues if you try to use a Unix box or something else. I don't expect that it would, but it's possible. Watcher would be a simple administrative tool. It would be designed to work with a standard terminal concentrator or with a bridge system. And what Watcher would do was it would watch the output from multiple telnet sessions. It's a telnet client that can have multiple sessions, so you can talk to like 10, 15, 20 servers at once via this out-of-band mechanism. And it would host a window for each session so that you'd be able to view what was on the window. That's interesting, but that's not much different from a typical telnet client. What is a little bit more interesting is it would keep a watch for certain text patterns. If these text patterns were specific, like for instance a blue screen, it could pop up a window dialog on the administrative machine, it would also create a WMI event. In the future, we'd look at expanding this to cover other WMI events as well. Currently, the blue screen is the only one that's instrumented like that. If this is something that's interesting to you, feel free to make that known as we give you another polling question right now. So that basically concludes my entire presentation. I hope you enjoyed it and found it interesting. I'd like to welcome Brian Valentine right now to talk to you guys. Brian.
How you doing?
Good. How are you doing?
Not too bad. So how's it been going today?
It's been going pretty well, I think.
All right. Giving a lot of good information?
I hope so.
All right. Well, I'd like to just take a few minutes. We have interactive questions coming in, correct?
We do.
So if you have a question and you haven't submitted it yet, feel free to submit the question. And so I think most everybody knows me. I'm Brian Valentine. I run the Windows group. So all I want to do today was, first of all, thank the people on the video conference or whatever you want to call the show, for being there today. But that's not the most important thing to thank them for. Obviously, the thing to thank them for is what they helped us with the Windows 2000. I know some of you have been involved with Exchange. Some of you are involved in the Office Advisory Council. And so that kind of participation we just love. And so thank you very much for that participation. Windows 2000, just to give you a quick data point, we've sold over 1.5 million licenses in Windows 2000 since we launched it. It's a great product. Support calls are well under what we thought they would be. Quality is up there. Customers are loving it. We're seeing lots of good deployments. And I really have to say that that isn't just Microsoft that did that. It was our JDP and RDP customers that helped us do that also. So thank you very much for that. And as we move forward, I mean, the vision I have for this program is to really take it forward in the sense that it's not just a deployment testing program at all. It really is a full 365-day a year, every year participation by these customers so they can help us design the next version of the product, set the priorities that are important for us, help us make those cuts, help us decide what should be in it, what priority, do all those kind of things. And that kind of input and feedback is very valuable because then we can target the products at their business solutions, their business problems, and we can really tackle their scenarios. So let's take the questions.
Don't have any yet.
No questions? Well, get them in.
So there actually was a quick question here on the headless features that we just talked about a second ago. I hope I'm not interrupting your
No, go ahead.
But until we get one of a question for you, take a step back. Will headless support provide the capability to echo session content to the system logs? Currently, that was not a feature that we had planned to do. I'll take this feedback and we'll investigate whether or not that is something that seems like it's both productive and possible to do, and we'll make a decision. But I appreciate the input, and if you have other input like that, suggestions, we'd be happy to take them. Feel free to form them in questions or just to say, I'd like to see this as a feature.
All right. Any questions yet, John?
No.
No questions? Come on, guys. You got to have at least one question.
You guys have got the vice president of the entire Windows operation here. You can't ask any questions?
I mean, ask a nice question. It's been a rough couple of weeks, let me tell you. It's been a blast running the Windows group over the last few weeks. So. So the weather outside's nice.
Yeah, it's been beautiful the last couple of days.
Can't see it here, but we're just rocking and rolling.
You guys have been lucky to come up here now. It was raining just a week ago, I think. But
yep. So who's all here? Who's our favorite people here? Everyone I know are favorites, but somebody's got to be the favorite first person to get a question in. All right, they're starting to roll in.
Okay, consumer focus. Do you want me to read it?
Yeah, why don't you read it since you got a better view of the monitor.
A lot of these talks to the JDP for enterprise, and we only see a little consumer feature in the UI shell sessions yesterday. Will Whistler be too heavy for the end user?
No, one of the, I'll touch on the consumer aspects of Whistler just to get people in sync. One of the key goals of Whistler, I mean, obviously it's to take care of and move forward on our enterprise space, business application space also, but one of the key goals is to drive NT technology or Windows 2000 technology into our consumer retail line also. To do that, you need to do a couple of things. We've got to get all the gaming, entertainment, devices that are important in that space compatible with the operating system, and we're doing that now. With Windows 2000, that wasn't a focus point for us. Even though we do have a lot of compatibility in there, it just wasn't one of the primary focus points. The second thing we got to do is when you look at Windows 2000, it really is kind of that industrial strength, enterprise ready stuff. It's got the Control-Alt-Delete logon. it's got ACLs, it's got all the event log stuff, it's got all those things that make it a great platform for the business, but it's confusing to your mother who just wants to send you email and browse the web, right? Or it's confusing to your family members if they have to, like, what does Control-Alt-Delete mean to log on and those kind of things. So we're definitely changing Whistler such that if you don't belong to a work group, and so if you have a PC that's not a member of a trusted domain or a work group, then it comes up in a different UI form that's really consumerish like UI that allows you to have multiple family members participate, allows you to have sections of your hard drive protected in just a simple way so you don't have to go worry about doing ACLs everywhere, but if you want to put your electronic tax returns in a spot you know your kids can't get to, it does that. It has some good system restore features, so if your kids go and install a game on the machine and it isn't a well-behaved game across the logo program or something, and you want to be able to restore back to where that game wasn't in the system and make sure you got clean uninstall of everything, it takes care of all of that kind of stuff. So, and it also includes the home networking capabilities of Universal Plug and Play, and includes lots of entertainment features around digital music, digital video, and those type of things. So we really are taking that technology, and it's really not, I mean, if you look at the kernel of NT, what Windows 2000 is built on, it's not that much bigger than the kernel of Windows 9X. It's just it was focused at different places, and we think bringing in all the reliability features and all the things you get out of Windows 2000 just from being on a better architecture is also a great benefit to the consumers. I mean, consumers don't want to reboot their machines any more than a business user wants to.
I would agree with that. So I have another question here for
Thank
you. We're constantly updating a punch list of missing or desired features. And Whistler seems to have come out of the box fairly well scoped. How can we get such a list submitted for the next version of Windows?
What we should do is obviously we're in the Whistler time frame now, and we're taking in that feedback, and there will clearly be discussions we have to have around priorities and what we're going to put in and what we're not going to put in. There is another release after Whistler. We're trying to scope those releases within 14 to 18 months so that we can actually be consistent and predictable on our deliveries. And obviously we'll have discussions around that next release. Those discussions will probably start up around this summer, late summer, early fall time frame about what are the priorities even for the next release. And when I say we're scoping them to about 14 to 18 months, I also realize that a lot of JDP and RDP customers are on longer product cycles or deployment cycles than that. And we really want to make sure that one of the key things we do is that as we deliver Whistler or we deliver the next release after that, they can maintain interoperability and compatibility with Windows 2000 if they're in the middle of a Windows 2000 deployment, and then also be able to jump up. So if we do the release after Whistler and they just finished their Windows 2000 deployment and they're ready to start their next cycle of technology deployments in their enterprise, they can jump up to that release, be interoperable with Windows 2000 and Whistler, and maintain all that compatibility. So we'll take the feedback just as soon as we start the intense planning around the next release of Windows out of our JDPs.
So in a similar vein, the staff here has asked me to ask you guys what you think of NetPodium. So feel free to provide some feedback right now on that. So one of the questions from the staff here is how quickly will back office and other MS apps get certified?
Obviously, there's a whole big wave of back office apps going in development right now around SQL 2000, Exchange 2000, and those kind of things. Those will be shipping this year, and as they ship, they will have the certification process ran against them just like the rest of the applications that want to get certified. Obviously, with certification programs, there's two things that are important. One thing is customers actually make buying decisions around the certification, so they believe that having a certified app is important to them, and that adds teeth to the certification. Even though Microsoft has it and we can add some teeth, the customers really add the real teeth. The second thing is, with every app that tries to get certified, there's always one or two exceptions that may occur around not being able to meet the entire specification. And we will certify apps with those exceptions so that then customers can make their own buying decisions based on, okay, that's a simple exception that doesn't really matter in my environment, and then I still want that app because that exception doesn't matter to me. But if that exception does matter to them, they can make the differentiation between a certified app that doesn't have that exception or a certified app that does, and make the buying decision around that. And so with the shipment of those products, the back office line of products, they will go through the certification process at that point in time.
Okay, so we have another question here. How will you be shipping new features? Only in releases like Whistler, in service packs, or downloadable feature by feature?
All three of those, but let me make sure I touch on the service pack issue. We will definitely have new features in every release of the operating system. So Whistler has a bunch of new features in it. Second thing is, as people discover things that they need, or we need quicker time to market between those kind of 14 to 18-month operating system releases, we'll also deliver those new features via either web downloads or on the Service Pack CD. But the difference in the past, from the past, is that the Service Pack CD, when you run update, when you slipstream in the Service Pack into your install tree, it only includes the bug fixes on the Service Pack. If we put new features in the Service Pack, they'll be through some custom install point where you can choose or not choose to install those features based on whether you need them or not onto your system, and then do your evaluation of stuff around those features. In the past, when you ran update.exe, it put bug fixes and features on there, and you didn't just get what you wanted if you just wanted bug fixes. So we'll use the Service Pack CD as a delivery vehicle to deliver utilities and features and functionality that people want before the next release of Windows. We'll also make those web downloadable, and then we'll roll those up into the next release of Windows. But we will make sure that the Service Pack CD has the capability of only installing bug fixes.
I didn't know that. That's cool. So let's take a look. We have another question here. Users sometimes bring their Office mobile PC home to work. How do we distinguish the same user on the same computer but different operating mode, say business mode versus personal mode? How do we firewall it within one box, within OS and content?
Yeah, what we're doing, if you take Windows 2000 today and it belongs to your enterprise domain, like for instance my laptop here at work belongs to the NT dev domain that we have. Well, I've got my own LAN at home, and that's actually going to be a much more frequent thing where people might have a single PC at home today, but where people are building out LANs at home either across wireless environments in the future or across 1 or 2 or 3 PCs they want to connect together at home. And the problem with Windows 2000 today is if you take it home and your credentials are in the NT dev domain like mine is, when I want to log on to my home LAN, I have to go and switch it into that domain, and then I lose the context if I want to dial back into my enterprise domain or DSL in or whatever way I get back into my enterprise domain. I lose that context in my credentials of my enterprise domain. In Whistler, we are fixing that such that you can take your PC home with you or your laptop home with you. You can say it's either now a standalone laptop at home, and it will shift, if you want to, it will shift the UI to be the consumerish-like UI on the front end, so it turns into family mode if you want to look at it that way. And then if you join it to your LAN at home, you can decide at that point in time whether you want the kind of enterprisey look on that LAN at home or whether you want the consumerish look on that LAN at home. But your credentials will move with you, so you can have your box actually be identified in multiple domains across the credentials, or be a standalone machine when you get home and then have credentials to belong to your enterprise domain when you're on the enterprise. And so today with Windows 2000, that's not an easy thing to do. It's a pretty manual step to make that work. And then you don't have the credentials across the boundaries, where in Whistler, you'll have the ability to be at home standalone, but also be able to use your credentials when you log in to your enterprise network, or if you're on the road or whatever, and have those work also in a work group or a network at home.
Okay, so another question here. How will you handle the interdependencies between applications and the OS? For example, Exchange 2000 uses the SMTP stack from IIS. How can Exchange support new RFCs without having to wait for a new OS release?
Exchange uses the SMTP stack in Windows 2000 and beyond, but Exchange has the rights to extend that if they want as they deliver. So we can actually, if Exchange needs support some new RFCs before we deliver the next version of the operating system, sure, the SMTP stack in the operating system as shipped won't have those RFCs. Exchange could have that RFC, and then we can make a decision as a company around the importance of that RFC and actually deliver that new SMTP component out of band of the next release of Windows on either the Service Pack CD that you can install separately instead of the bug fixes, or as a web download or something like that. So if it's important enough from a business reason or a customer reason for us to actually deliver that out of band from the operating system, we have the flexibility to do that.
It looks like we've got some net podium comments here, but we're out of questions for the moment. So come on, guys, more questions.
Got about 2 minutes, 3 minutes left, so feel free to dump them in, or we can be done now.
There's a couple more questions here. Look at number 21.
No, I think we got that one. I think we caught that one. Oh, here's one, though. No, that's input on net podium. Well, you guys are doing a great job on commenting on that podium, which is good.
The JDP folks are never shy.
And that's good as well.
Right. All right, well, I guess, are we done, John?
Did you get 23? Yes. Okay. Yeah.
All right, well, it looks like we're done then. So just in closing, I'd like to thank everybody for participating. And I do appreciate you taking the time out of your day to come and listen to us about this stuff. And thank you again, and I really want to turn this program into being a great program, not only for us to be able to build great products, but for you to also have those great products used in your environment. So thank you very much, and I'll see you next time. All right.